Good day, everyone. My name is Xiaoyu Zhang. My metric number is B091910300, and my course is BMMA, and I come from Section 1, Group 2. My supervisor is Dr. Noor Haswani binti Mokhtar. So today, I'm going to present about the research on effect of oncoming vehicle size on overtaking judgments. So for presentation outline today is the introduction, followed by literature review, methodology, and lastly, the initial result. So for introduction, for the background of study, in the old days, automobiles are created to enable people to relocate easily. Nowadays, automotive technology is advancing, and most of the automobile manufacturers are focusing on the performance of the automobile. So the speed of an automobile is increasing. Therefore, a safety concern is created, which is the road accident. And the number of road accidents is growing also because of the increment in the number of automobiles on the road. So according to CEIC data, there is 70,728,428 vehicles registered in December 2021 in Malaysia. So that is a huge number. So human error is the main factor in road accidents such as carelessness, reckless driving, distracted driving, and overspeeding. One of the common example is using mobile phone during driving. So to reduce the road accidents, the automobile manufacturers has introduced the Advanced Driver Assistance System (ADAS). For the problem statement of this research, so one of the causes of road accidents is avoiding front obstacles to prevent a collision. So it may lead to losing control of the automobile. So such as the rollover may happen. And so there's a need to create a scenario of an automobile avoiding front obstacles in a straight line in real time to understand the vehicle dynamics. But normally, the vehicle dynamics in this scenario will be evaluated using MATLAB and conducted in a driving simulator. So in this research, an Arduino-based monitoring device will be used to understand the vehicle dynamics. For the objective of this research, there are four. The first one is to design, develop, and analyze a questionnaire study to determine the user requirement for the specification of a driving behavior monitoring device. And the second is to design and develop a device to measure acceleration, angular acceleration, temperature, and location of an automobile, followed by to design an experiment to determine automobiles drivers' behavior towards avoidance of front obstacles. And lastly, to analyze the experiment data or result by using statistical method. For the scope of research, the questionnaire study is limited to 61 respondents only, and the maximum of range accelerometer is plus minus 16 gravitational acceleration. Maximum range of gyroscope is plus minus 2000 degrees per second. The range of temperature is only negative 40 degrees Celsius to 85 degrees Celsius. And lastly, the experiment participant is limited to 10% only. For the second outline of today's presentation, literature review. So literature review is an academic writing that discusses the information of published articles in a particular subject area. So it also demonstrates the knowledge and understanding of the published articles on a specific topic in a context. So information and knowledge that is useful for this research has been collected and act as a guide in completing this research. So for the first one is the accident statistic. So as we can see from figure 1, it is the Malaysia road accident 2010 to 2019. So the number is increasing constantly from 2010 to 2019, which is from 414,421 cases to 567,516 cases. And for the right side is the Malaysia road fatalities from 2010 to 2019. So for the first 4 years, the number is constant, and there's a slightly drop in 2014, and there's a sharp increment in 2016, which is the highest fatalities, 7,152 cases, and the numbers starts to drop after 2016. So this statistic is from the Ministry of Transport 2020. So, and additional information, the transport accidents were ranked as the fourth principal cause of death in 2018, according to the Department of Statistics Malaysia. So for accident avoidance technology, there's a paper named Intelligent Advice System for Human Drivers to Prevent Overtaking Accidents on the Road. So the researchers has found that the miscalculation and misjudgment of time to collision, TTC, during overtaking maneuver can lead to an accident. So they have proposed an intelligent overtaking advice system, IOAS. So the IOAS will convert the distant information provided by the virtual LiDAR sensor into TTC and advice for overtaking. So from figure 3, it is an overtaking scenario with EGV, which stands for ego vehicle, LVF, lead vehicle front, and LVO, lead vehicle opposite. So the virtual LiDAR sensors will provide the system the velocity of the opposite vehicle and front vehicle, and also the distance between them to calculate for TDC. So the researchers found out that 10 seconds of threshold TDC is safe for a human driver to complete an overtaking action. So when the TDC is more than 10 seconds, the system will advise the driver to overtake. So for previous study, a risk field-based metric correlates with driver perceived risk in manual and automated driving test track study. So the objective of this paper is to test if the DRF-based risk estimate could predict manual driving behavior and the driver perceived risk during automated driving. So DRF, driver risk field risk estimated, is used to predict the probability of an event to occur and calculate the cost of the event. So as we can see from figure 4, it shows the schematic representation of the driver risk field. So for the blue part, it represents the low cost, and for red, it represents the high cost. So this is helpful in assisting the takeovers by the driver, as it can predict the manually driven trajectory. Next to our methodology. So after the literature is done, we design survey question, which is as follow. The section 1 is demographic profile, which include the gender, age, and class of driving license. And for the section 2, it is the device specification, which need the respondents to rate the importance of the specification. So there is 8 specification listed here, and 1 is represents least important, and 5 is representing most important. After the survey question is designed, so the survey is distributed and the data is collected. So the survey is conducted using Google Form, and it is distributed through social media like Facebook and WhatsApp, and 61 respondents are involved in this survey. So after 1 month, the data will be collected from the Google Form and downloaded in an Excel. So the data collected will be analyzed using statistical method. So the percentage will be calculated by using number of respondents divided by total respondent times 100. And for the specification weight, It will be calculated by total number of rating 4 and 5 divided by total respondent times 5. So after the data analysis is done, we will start to select the sensors. So for selections of sensors, the first sensors that is suggested is Arduino Uno Rev3. So it is a microcontroller. It can act as a mini computer that can be programmed with the Arduino software IDE. So it can be downloaded from the website without any charges. So it is a low cost, flexible, and easy to use programmable open source of microcontroller board. For the second sensor is GY521 module. So it has three functions. The first one is accelerometer, and second is gyroscope, followed by thermometer. So the range of accelerometer is plus minus 2, 4, 8, and 16 gravitational acceleration. And for the range of gyroscope is plus minus 250, 500, 1000, and 2000 degree per second. And for thermometer, its range is negative 40 degrees Celsius to 85 degrees Celsius. So this sensor is selected to measure the acceleration, temperature, and steering angle of the vehicle. For the next sensor is GY-GPS MU2 module. So it is used to provide GPS function, and the antenna at the right side of the figure is used for better reception. So it has a high precision of measurement, only 3 meters of this difference on average. So it is a low cost yet powerful GPS receiver. And lastly, it is the Node MCU. So it is an open source Internet of Things platform. So it can connect objects and transfer data through Wi-Fi protocol. So it can transfer the data without connecting the device to the computer. So real-time data can be sent to a computer. And also it is a low-cost sensor. For the last part for today's presentation, the initial result. So a survey analysis is done after the data is collected of the survey question. So for the first section is the demographic profile. So from table 1, we can see that most of the respondents are come from an age group of 16 to 25 years old, which is 46 of them. 75.4% of the total number of respondents, and most of them are male, which is 40 of them. And most of the respondents are having a driving license. Only 2 of them are not having a driving license, which is only a small amount of the total respondent, which is only 3.3%. So we can conclude that most of the respondents have a minimum of 1 year and a maximum of 9 years of driving experience. So their suggestion is reliable. For the second part, it is the device specification and rating. So from table 2, we can see that there's a huge number of respondents suggest that the accelerometer and global positioning system GPS as the most important specification of a driving behavior monitoring device because of its rating is 5. So for the other specification, there are no specification rates below 4, which means that all of the specification listed in the survey should be implemented to achieve a better result. So thank you for watching this presentation and have a nice day.